Okay, hello everybody. I have here just a picture actually of your group test key, and I'm going to go over each problem. So you can watch this as many times as you feel necessary. You know that your actual test is going to look a lot like this. So I think if you just practice these problems enough with maybe the review sheet and other problems we did in class, it should have you pretty well set up for success on the actual test, because there's only so many ways to ask these questions. Okay, on the first one, we have a quadratic that's in standard form. Remember, standard form is a number times x squared plus another number times x plus another number. We have seen where like these two numbers don't even actually have to be there. It could just be like x squared or 5x squared and still be in standard form. The other two forms, this is vertex form. Vertex form is always where it's something squared and then plus or minus a number out here, or that number could be 0, so maybe that number's not even there at all. And then factored or intercept form on the third problem is what we call a double bubble. So you'll see two sets of parentheses there. There could be another number out here, like an a value. Right now there is an a value there that's equal to 1, but it could be some other a value. So you do have to be able to identify those on the test and just say which is which. But let's come back up here to our standard form problem. When it's in standard form, you have to know that x equals negative b over 2a is how you find the x value of the vertex. So here's our b value. You can see over here in orange, here's our negative, which stays there. Our b value itself is positive, so I put 4 there, over 2 times our a value, which is the number right here, negative 2. Evaluate that, and you get 1. So that is the x value of our vertex, which is also therefore the axis of symmetry is x equals 1. To get the y value of your vertex, or to get any y value ever, you can pick whatever you want for x and plug it in to get the corresponding y value. So I can plug in 25 for x if I want, and I'll get a number, and that will be the y value on the graph when x is 25. It would be 25, comma, whatever that number is. But I'm not going to plug in 25 because that number is too big. I am going to plug in 1, which I've shown right here, and for this x, and evaluate this, and you get 3, so that's the y value of the vertex. Just be careful if the 1, whatever you plug in for x, if it was a negative number, every time, it's going to be the same every time. When you square this, this will turn out to a positive, then you multiply by the number out here, which would turn it back into a negative in this particular case. And then if you had a negative in here, you got to be careful of that, or a minus sign, because then that would turn it into a positive. So just be careful with that. But if you type it correctly on a calculator, it will give you the right answer, but sometimes people type it incorrectly. Okay, the y-intercept of any function ever, and I write it for you right here. I'm telling you x has to be 0. In standard form, the shortcut is just notes the c value right here. But if you don't know that, just plug in 0 for x, because that's how you find every y-intercept ever in all 3 forms that we're going to talk about on here. So plug in 0 for x, and this turns into 0 times negative 2 is 0. This is 4 times 0, which is gone, and you just get 1, which is why it's exactly our c value right here. Okay, the domain of any quadratic ever is negative infinity to infinity. The range is going to be either negative infinity to the y value of the vertex, or the y value of the vertex to infinity. It depends on if it goes like this, so vertex and then up forever, or if it goes like this, which means it comes from down forever up until the vertex. So this would be negative infinity to the y value. This one is y value to infinity. Okay, and you can know that based on your a value. Since our a value is negative, we know that this quadratic opens downward. And so therefore it has a maximum, and that maximum value is 3, which is just the y value of the vertex. So therefore our range goes negative infinity to 3. Okay, and now I am asking you to show 5 clear points. From this information, we already have 3 points. We have our vertex, 1, 3, which you can see right there. We have our y-intercept, 0, 1. So we know those two just from the information I'm asking you to find. Then because of symmetry, you know this point automatically. Now find any other point. The easiest point to find is just go 1 x value bigger than the x value that you have currently. So we know when x is 2, y is 1. So let's plug in x is 3. So I've shown that work over here. I'm just going to plug in x equals 3 to find another point. Then I can use symmetry for the fifth point. When I plug in 3, just like when I plugged in 1 over here, okay, plugging it into this, I get -5 for my y value. So we're at 3, -5, which means because of symmetry, we're automatically right here as well, because we have our axis of symmetry going down right there, which I didn't draw on these graphs. You don't need to draw that, but if you want to draw it as a dashed line because that's helpful to you, then by all means, go right ahead. Okay, so that's how we're going to get a fifth point, really the fourth and fifth points on all these graphs. All right, now when we're in vertex form, our vertex, remember from our horizontal shifts in our last unit, this shifts a graph left 1, down 4. So our vertex is -1, -4. Therefore, our axis of symmetry is x equals -1, always the y or the x value of the vertex. The y-intercept in this form is not this number. That's why if you don't even have to remember it's this number in this form. Just know you plug in 0 for x, which again, I have shown you right here. This is your x value. I'm telling you it's 0. Plug it in and get your y value. So I've shown that work right here. I'm plugging in 0. You can see how I evaluated that, and I got -3. So there's our y-intercept. So now we have the vertex, we have the y-intercept. Here's my vertex, here's my y-intercept. Because of symmetry, I have another point right there automatically. Domain for all of these is -infinity to infinity until we get to word problems. Range, since the a value is positive right here, is going to go from the y value of the vertex up forever. So -4 to infinity. Since it opens upward like this, we know we have a minimum. The minimum is, again, the y value of the vertex. Okay, so here's the points I've already plotted. Then, since I know the y value at 0, I'm going to plug in x equals 1 and find the y value. So that's what I've shown here, because that's just one number higher than the x value I already know. So since I know it at 0, I'm going to find it at 1. It's just the easiest one to do. So I plugged in 1 right here, showed that work here, and I got 0. And then again, because of symmetry, here's our axis of symmetry. You know you're going to have another point right there. And there you go, 5 points. Okay. On the next problem, you should know that this is factored or intercept form. So just by looking at this, we know the x-intercepts are whatever make our bubbles equal 0. So try not to fall into the trap of thinking that this one you get 4 and this one you get 6. Because if you plug in 4, 4 plus 4 is 8. You're supposed to get 0. That's why it's -4. And that's why this one is -6, 0 for our x-intercepts. Okay. Once you know the x-intercepts, you should know that the vertex value for x is halfway between the x-intercepts. So halfway between -4 and -6 is -5. Once I know it's -5, I'm going to plug in x equals -5 up here, just like I've done on the other problems. Calculate or evaluate this, and I get -1. So my vertex is -5, -1. So now I already have these two zeros. The x-intercepts also, they're also called zeros. And then I know the vertex. So I already have 3 points. Now I am having you find the y-intercept. Again, I'm telling you x is 0. Plug in 0 for x. I've shown it here, and you get 24. Remember, you multiply these two values together. That's what bubbles next to each other means. But this is way off the grid, so I'm not going to use that number. I'm just going to find any other point. What am I going to plug in? -3, because it's one number bigger than what I've already plugged in. So I showed that over here. Plug in a -3, and I get 3. So -3, 3. Then because of symmetry, I know I have another point right there. And there's my 5 points. Domain, once again, is -infinity to infinity. This parabola is opening up, so we have a minimum. The minimum value is -1, which is the y value of the vertex. And our range, therefore, goes from -1 to infinity. Remember, on all these, all numbers that are in domain or range will be inclusive and never inclusive on infinity or -infinity. Okay, on to page 2, the word problems. Now, all the same information is important in these graphs, and we just need to understand what the question's asking. So this is a soccer player kicks a ball, and the height, I should say in feet, of the ball after t seconds is given by the equation on the right. So here's our function right here. What is the ball's initial height? The initial, whatever the problem is talking about, initial cost of something, initial height, whatever the problem is the y-intercept. And so 1 foot is our y-intercept right there. And these points are labeled for you so you can figure that out. At what time does the ball reach its maximum height? Well, its maximum height is the vertex. That's what a vertex is. So its maximum height takes 2 seconds to get there. And then the actual maximum height then is the y value, 21 feet. It's the y value of the vertex. How long is the ball in the air? Well, the ball is no longer in the air once it reaches a height of 0, which is an x-intercept. And so the ball starts at x equals 0, which is not here. That's this point. This point actually is not useful because that's negative time. So you start at 0, and it was in the air until right here. And so it has been in the air for exactly this many seconds. And the domain as it relates to the problem, well, that just means how long, like the total time interval that the ball was in the air, and that will be from t equals 0 until the ball hits the ground at t equals 4.04939. No reason to round this number since we can just see it right there. You can just write it all. Okay. And lastly, this is a company sells a product. Its revenue is given by this. Uh-oh. Bear with me. It's going crazy. All right. Its revenue is given by this function. Revenue is how much money comes into a company. Cost is how much money goes out. And then profit is the difference of those two. How much money comes in minus how much money goes out. So revenue minus cost. This problem doesn't have anything to do with cost or profit. I'm just explaining to you what revenue is. Okay, so this says what price per unit maximizes the revenue. Well, if you're trying to find a maximum, that means you're trying to find the x value of the vertex. The actual maximum is the y value of the vertex. This is the price that maximizes it, and x is the price. So we just want the x value of the vertex. Since this is an intercept form, or factored form, we know that the x value of the vertex is halfway between the x-intercepts. Our x-intercepts, we get 6 from here, because that makes this 0, and we get negative 4 from here, because that makes that 0. Halfway in between 6 and negative 4 is 1. Now this is measured in thousands, so 1 actually means 1,000. A lot of people didn't write 1,000 on the group test. In fact, only one group did. I didn't take off for it, but maybe you should pay attention to that in the future because it does say in thousands. So the number 1 actually represents 1,000. The number 100 represents 100,000. So now what is the maximum revenue? Well, you know the maximum revenue exists when x equals 1. So plug in x equals 1 into here, which I've shown here, and multiply it all out, and you get 50. Now, again, that actually means $50,000. Okay? And then what is the revenue when the price per unit is $0? That's really just the y-intercept, but you don't even actually have to know that. They're telling you what the price is. Plug the price in of $0 right here and here, and then multiply this together, and you get 48. And so the revenue is 48,000, but because it's measured in thousands. And then D, for what price range does the company generate revenue? That is just the x-intercepts, because this graph's going to look something like this until it gets out to 6 right here. So it generates revenue from 0 to 6. You can't count the negative ones because nobody's going to charge a negative amount for their product. So you could say 0 to 6. I had that at first, and then I crossed it out and said $0 to $6,000. But if you read it like this, it shows understanding. So, all right, so there you have it. That's pretty much your whole test in a nutshell. So watch and rewatch this video and practice these problems and your review sheet. And study hard. I know that you guys can do really well on this test.